FS lab is about hashing. So we will learn what hashing is first of all, and then try to implement what is present in the 11th program. Okay, so hashing, what is hashing? You can consider hashing as a box or a function, okay, some function which takes a key as the input and gives out the index. Okay, so it does some kind of a functionality here, some kind of a manipulation, whatever it is, some kind of a mathematical function. So the input for that hashing function is the key, and the output after the manipulation is the index where the record with this particular key has to be stored, right? So if we have to take up an example, this is how it would be. So let's consider I want to store 10. Okay, so one of my hashing function would be like I'll add the place value of these two. So I'll add 1 plus 0. So now what I got 1. So now this 1 is the index. So if you have an array where you have to store all these keys, then this is the array where you want to store, and these are the index, right? Okay, so the size of this array is 10. So what you're supposed to do is you're supposed to mod it with 10 so that you will get an index that is valid, so that you can go ahead and place it there. So you got, after addition, you got 1 mod 10 is 1. So where are you supposed to go and put the key 10? So you're supposed to go and put it in index 1. So you're going to place it here. So next time you want to search the same key, it is very easy. Feed the same key to the function, compute this, you will get the index, go there straight away, you will get the element, right? So let us take one more example of a different key. This time let's consider 20. Right? So now what's the computation? So we'll add these two digits. So 2 plus 0 is equal to 2, and mod 10 is our hash function, so which will give you 2 again. So where are we supposed to store this? So we're supposed to straight away store it here, right? So next time you want to search 20, again do the same computation. 2 plus 0, 2 mod 10 gives you 2. Go there and place it in the index, or go there straight away, you will get that key, right? So this is what is going to happen in hashing. So your hash function can be as simple as adding the digits that are there in the number or the key, or it can be any complex hashing function which will give you some kind of a distinct index, right? So this is what it is. But then there is some problem here. What if my hashing function was adding the two numbers that were there in the numbers, and I give something like this time, right? Say I'll give 0, 2, right? So according to my hash function, I'm supposed to again add 0 plus 2, which will again give me 2, and mod 10 will give me 2 again. So 0, 2 is something which I consider as a separate record, a key. In my case, 2, 0 is different and 0, 2 is different, right? So now if you follow the same hash function, you will get 2 as the index. But look what has happened. 2 is already consumed. There is already a key present in this third index. Now can you override this? No, you can't. But you are not supposed to lose this key as well. So you are supposed to write it somewhere in the array. So this situation is called as collision. Now there are different methods in which you can resolve this collision, right? So one thing would be to go for separate chaining. The other one would be for double hash, that is you hash again and then you search the next available slot. Okay, search the next available slot and then put it there. So these are different types of collision resolution techniques that would be covered in your theory part, right? So this is exactly what we are supposed to do in this particular lab. Now let's see how exactly it is going to work in your lab program. So in your lab program, you have a file in which you are supposed to write all these records that the user gives in a fashion that you can straight away go to that particular location in the file and fetch that record. So what is going to happen here? You take the USN as the key, say for example 1JT12IS001, and then what are you going to do? So this whole, instead of taking this whole thing, because this whole thing, this much is constant, right? So we don't want to consider that part of the key which is constant for all the USNs that we are going to enter. So we're going to take only this part which is going to vary. So what we're going to do here is, when we write, when we take the input from the user, we should understand that these are all characters. So if you have to do some kind of an arithmetic, then we will have to get the number out of this character. So what we are supposed to do is character 0 minus 48 gives you 0, that is integer, right? So we are supposed to do the same thing. Again, character 0 minus 48 gives you 0, that is the integer part. Again, 1 minus 48 gives you 1, that is the integer part. Now you have the numbers with you, and now you can do any kind of mathematics you want. So I think in the program that we are going to see, what they've done is they have taken 0 into 100, 0 into 100 plus 0 into 10 plus 1. So this will ultimately give you again 1, right? Mod, whatever is the size of the record that you have chosen, we consider that this program follows a fixed length record. So if the fixed length record is 45, length of the size is 45, then you get again 1. So go to the file, go to the first position, that is 1, and start putting your record there, right? So this is exactly what is happening. Now if you consider some other USN number, say 23 or something like that, then possibly you will get a different answer. So 0, 2 minus 48 gives you 2, and 43, 3 minus 48 gives you 3. So 0 into 100, 2 into 10 plus 3. So 23 mod 45 will again give you 23. Right, so go to the 23rd place, right? Or you have to make sure that you're not supposed to overwrite anything here. So say you have the first record that you wrote was from 1 to 45. So what you are supposed to do is, for this you are supposed to add 45 and then write it elsewhere and then have that as the index. So pretty much this is what is going to happen in the hashing function. So next time when you want the same USN, follow the same thing. You will get the index, go to the location in the file. This is you can consider this as your record.txt, where you're going to write all the records. Go to that location straight away. You're going to get the record and then you can access it, right? So this is about hashing. Now here also there is a possibility that there will be a lot of collision, right? So what you're supposed to do is, when you create a record, when you write a record, you should consider that from there you're not supposed to write for the next 3 record space. Okay, if you consider 45, leave one space, next 45, next 45. So this much you are not supposed to write any other record but for those which generate this index, right? So this is how you handle. So this will be like somewhere around separate chain, right? Separate chain collision resolution technique. So we'll see how exactly it works when we run the program and see it. Thank you.
So lab program 11. Here we are supposed to write a C++ program to store and retrieve student data from file using hashing. We are supposed to use any appropriate collision resolution technique in case there is a resolution. Now let's start exploring the listing. So as usual, there is a class called a student, in which you have string, name, USN name and SEM and all that, and you have enter data, display data, pack, unpack and other things. Apart from these, we have something called as hash, which will return an integer that is supposed to be the index, and string is the input to this hashing function, the key, in our case the USN, right? And then we can search also a particular thing and then error. So let's start exploring it. So initially we will try to open a file called as record11.txt and see if something is already there in that, and then close it. If it is not there, it will create it, and then we'll ask the choice as usual to the user. So there are only two choices, insert a record and search for a record. Third is to exit. So if he chooses to enter a record, then we'll straight away go to enter data, where we take all the details, and the next thing immediately that we're going to do is to call pack. So in pack we know that this is a fixed length record that we are talking about, so we are going to pack it completely and check if the buffer length is greater than 42. If it is greater than 42, we will throw an error saying it is too long. If it is not, then we are going to fill this buffer with these padding characters. Exactly after that, we are going to call this hash function on USN. USN is our key, as we already told. So once you call hash function, it will come here. So USN is the thing that is taken, and then what you are supposed to do is the last 3 digits in the USN will be the roll number. So take those digits, and as we saw in the explanation, we are going to add the place value of each of these and then mod it with 9. Why 9? We will see it. Okay, so mod it with 9, and whatever you are going to get, we are going to multiply that with 142, that is 3 records in a particular position, that is index. Okay, so that's why it is 142, or it can be anything less. So this is our hashing function. It's going to give this number to us. So this is exactly the position where we are going to write the record in the file, right? As we saw in the board presentation. So we're going to consider the last 3 digits in the USN. Why minus 48? Because whatever is there here is a character, and we want the integer out of it. So we're going to reduce that offset, right? Minus 48 ASCII value. So we're going to get the integer of this particular character number. So exactly after that, we are going to come back here. So this is what is our position. So that's where we are going to write the file, write the record, right? So we are going to write the record here, right? So we are going to check whether we can open the file, right? If we could not open the file record1.txt, we are going to throw an error again. Otherwise, we will straight away go to that particular place where the hashing function said to go. Hashing function gave us this position, so that's where we are straight away going. So we go there, and remember, we are also supposed to handle the collision. If there are already 3 records that are written in the same position, we can't write the fourth one. So how to check that? So there is a small arrangement that we have made here. So the very first character will be the count. Okay, initially the count will be 0. So we are going to get that line there. After going to that position, we are going to get the line, close the file, get the count. How are you going to get the count? Count will be here. You are going to read the line into temp, and the very first character is the count. So if the count is equal to 0, then there is this error that you can't put some more records there in the same position. So then you're going to return. Otherwise, you're going to open that file. Okay. If the count is less than 0, then that is the place where you are supposed to put the record. So simply go there, put 1 because you are writing the very first record, and then say position is equal to position plus 2, because exactly after the count you start writing the record. If there is already a record there, then you are supposed to put 2 there and then say position is equal to position plus 48. As I already told you, we have the arrangement made for 3 records of size 46. So we have left few spaces, and then we are writing it after that, after those many number of characters. So if the count is already 2, then put 3 there, and then from the position add 95 characters so that it goes beyond 2 records, and then writes the third one after the 2 records. So this is how we decide where to write the record, and then ultimately we are going to show up this thing where we say inserting at such and such a position, and then we are going to seek to that particular position and put that particular buffer that we packed just now there, and then close the file. So this is exactly how we are supposed to insert a record into a file with hashing. And then the next thing is of course search. Now search becomes very easy because now we need not do any kind of sequential processing. We just need to take the USN to be searched. Again, we just need to hash it. Now when you hash, we know already, we saw how hash works. We are going to get the position straight away as to where this particular USN, if at all it is there, is stored. So we straight away go there, seek to that particular place in the record.txt, and then get the line and then get the count. Okay, here we need to worry about the count also because we are handling the collision. It's not that straight away there we are going to get this USN itself. Different USNs would have hashed to the same position, right? This is called as collision, and we have handled it. So exactly after going to that particular position, from the next character we are going to again traverse. This is where sequential processing again starts, but no, don't worry, because this sequential process is very less. We are going to compare only 3 different USNs that are present here. So we are going to unpack, get the USN that is present here, and then compare it with whether the USN that we need matches with this. If it is there, then we say flag is equal to 1 and break. Okay, so fp.close. Once you do this sequential search after getting to that location, you close the file, and then if the flag is set, then record found and display the data, else record not found, and we are simply returning. You know, unpacking is something which we have already seen enough number of times. So simply unpacking display data is also something very, very trivial. But these are the different errors which we are going to call at different. So unable to open the file, or data exceeds record length, cannot insert maximum number of collisions allowed is 3, things like that, right? So this is exactly how the program actually is written. Now we'll see the demo. Compile this particular program first initially, and then run it. Okay, so this is the way we compile it, and before we run, we make sure that there is something called as record11.txt already present, and then as usual we will try to have a watch on that. So we'll run this. So initially there is nothing in the record 11.txt, and then as and when we start filling the records, we will start getting the things there. So let's run this program. So initially it is asking us to enter the record. So let's start entering 1JT12 IS001 Adiraja 6th semester. So this got inserted in 569. So here it is not going to show us exactly as to where it is inserting that, but it is getting inserted at that location. But observe that here we have that one extra. So 1JT12 IS001 is our record, that RUSN, but that one is the first record in that particular location, right? So we'll try to insert one more record, 1JT12 IS010, right? Vibhar something, and then 6. So this also got inserted at 711. Now 711 is a different location, so we have written 1 again, the very first one, right? And then we let us insert one more, 1JT12 IS0 or 100. Okay, so name would be something like issue or something, 6th semester. So this got inserted at 758. So now 758 is where it got inserted, and please observe this time it did not show 11JT because it got inserted here. Now if it is not very clear here, what we are supposed to do is we are supposed to see the record file itself. Now we'll try to open this 11th record and see how it actually looks like. So this is how it actually looks like, right? So this is where the first record is written, and this is where the other two records are written. So please observe, the second time when our USN was 0, 1, 0 and 1, 0, 0, there was a collision. The hash function created a collision and it had to insert in the same location where it had inserted this. Now, because we can't overwrite or do anything now, and because we have maintained a lot of space, we are in the same location. We are changing the thing to be 2, number of records to be 2, and then we are inserting it after this first record, right? So this is exactly how the collision handling actually takes place. Now if there is one more record that collides with 001, that is this place, then this gets changed to 2, and one more would be written somewhere here exactly after this record, right? So this is collision handling. Now we will try to search a particular record, that is 2, and then we'll search this last one that we just inserted, and it says the record was found and this is the record, right? So this is exactly how the hashing function actually works. Now what would have happened when we searched? The same hash function is again called. When we try to insert, it gives you 758, it goes to 758 location, and it gets 2 different US records, right? So the first one is this, but this is not the one which we are searching for. We are searching for this, so it shows us that, right? So this is exactly how this works, right? Thank you.